Hello, Wilson here again, and then this video is about the necessary biological skills that you need to master in Unit 1. Now, there's three: how to make biological drawings, how to calculate magnifications, as well as how to construct a dichotomous key. Now, let's start with the video. Now, the first skill is to how to make a biological drawing. Now, there are several points. For example, if you have been given a question like this to ask you to, for example, draw a picture of the orange that has already been given in the picture, use all the spaces provided. You can't just draw like a miniature 5 centimeter across orange on a full page. You know what I mean? Because it's really hard for people to see, and you'll not get full marks for it. And also, when you're drawing, always use a sharp HB pencil, because this is the rule, right? If you want to draw something, you might make a mistake, and then if you draw something wrong, you can't rub it out if you're drawing with like a ballpoint pen, for example. So always bring a pencil into your exam, as you might not know whether you will be given a drawing question or not. Well, biological drawings are not artwork, right? You don't need to, for example, like draw a masterpiece for art and then be expected to get full marks. Keep all the lines that you draw clear and single lines. No doubling lines, no shading, and no color. And also, you need to draw to the right proportions. For example, if you've been asked to draw a picture of a cat, you can't just draw the head 3 times as big as the body. You can't do that. That's not accurate. And also, you need to label your drawing. Now, labeling is something that students often forgot how to do and don't care what to do, and they lose marks for it. If you are labeling your drawing, use a ruler to draw the lines and make sure that each of your lines touch the part which you want to label. For example, if I'm labeling the ears of a cat, my lines will have to physically touch the ear to be able to label it. If you don't touch it, you might lose marks. Now, these questions in the exam will often be, for example, 4 marks or 5 marks. Now, this is the easiest marks you can ever get, and it's quite high. 5 marks is quite a lot. And then anyone who don't get this question correct or full marks for it should just be given a automatic D. You know what I mean? Because this is ridiculous. It's even easy for like beginner biologists. Next, here's a picture of a flower that I've drawn in class. You can see that my flower takes the whole space that's been given, and then I've drawn using a sharp pencil with no shading, no color, and only single lines. I've labeled using a ruler, but now that's not quite true. I've drawn some lines with freehand, but just remember to draw labeling lines with a ruler. And you can see that when I label the petal on the top right hand corner, you can see that my line is physically touching the petal. Next is magnification. Now, some things in biology can be really small, for example, like a cell. And then when scientists need to draw a picture of that, they'll have to draw it really big for us to see it. Now, you'll often be asked in the exam to calculate either the magnification of a drawing or the size of the real object that the drawing shows. Now, magnification equals to the size of the drawing divided by the size of the real object, and the size of the real object equals to the size of the drawing divided by magnification. For example, the size of the drawing of a spider is 40 millimeters long. The real spider is 8 millimeters long. What is magnification? Well, magnification equals to the size of the drawing divided by the size of the real object. The size of the drawing is 40 millimeters long. The size of the real object is 8 millimeters long. So the calculation is 40 divided by 8 equals to 5 times. So basically this tells you that the size of the drawing of a spider has been magnified 5 times bigger than the real spider. And also, one thing you need to remember when calculating magnification is that you will need to use the same units throughout. For example, if the units given in the question is in millimeters, then your working should also be in millimeters, and your answer should also be given in millimeters. For example, and then the same, if you have been given nanometers, you should use nanometers throughout. And by the way, 1 nanometer equals to 0.000000001 millimeter. That is 1 times 10 to the power of 9 millimeters. next is how to construct a dichotomous keys. Now, a dichotomous key means that a key that's being constructed using the method of splitting into two. That's what dichotomous means. Now, this is a tool that a lot of scientists use, and it's a very, very simple and easy to use tool, an effective tool that you can use to identify an unknown organism. And then the way you should construct it comes in 3 steps. The first one is you need to make a list of features that clearly vary between the species of living things that you are going to identify. Then concentrate on a group that has more than one living thing. Pick a feature that will split them into 2 groups and keep doing that until each group contains only one living thing. The third step and the last step is to go back and refine your key. Think carefully over your wording for each pair of statements and something else. Now here's a picture of a dichotomous key that's been constructed by someone else. You can see that this key is used to identify invertebrates. It's been given a title. Now, this person has cleverly split the invertebrates into 2 distinct groups. One is symmetrical, one is asymmetrical. Now, for the asymmetrical one, the guy immediately gave the organism called Porifera, which is obviously, well, it looks like a sea-dwelling organism. Well, now for the symmetrical group, this guy continued to split this group into 2 separate groups, which is radial and bilateral. This means that they're body shaped. For the radial one, we are immediately given a jellyfish. For the bilateral one, we are split down into 2 further groups, which is, well, with a very, very funny group, which is a group of invertebrates that have anuses and one with no anuses. Now, for the no anus group, you have been given a sea-dwelling worm, some kind of things. Now, for the anus groups, it is continually split down into 2 separate groups, which is invertebrates with no visible segmentation or with visible segmentation. Now, for the no visible segmentation, which means their body parts, are they segmented or not? We're given the octopus. For the visible segmentation part, we are split down into last 2 groups, which is a group of animals that have no exoskeleton and one with exoskeleton. Now, on the right hand side, you'll see that it has given the earthworm. Now, for the right hand side, you'll be given a spider. Now, this dichotomous key focuses on only invertebrates from either on land or in the ocean or in the water. Now, in the exam, you might be asked to construct one, and then you'll be given like a specific group, not as varied as this one in this picture. And then it's always quite easy to draw if you know the method to draw it, and then if you know what you're going to split each group down into which groups, then it's very, very straightforward. Now, I'm going to end this video here, and this is Unit 1 finished. I hope that you guys have learned something from it. This topic is a very, quite straightforward topic. It is just that you have to remember a lot of things in this topic that makes some students frustrated because they have to remember a lot of things. Well, it's quite weird, but you have to do it. Now, these 3 skills are one of the basic skills that biologists needs. It's quite straightforward to understand, and it's not that easy to use when you're actually going to use it. Now, the next set of videos I'm going to be doing about Unit 12, which is excretion. The reason I'm not doing videos as in order of the topics is because that a lot of classmates from my school is asking me to do Unit 12, so I thought, why not do it? You know, just it's also like as a method of revision. So I'll see you guys there. Goodbye.